All right, guys, in this video, we're going to be taking a look at a little bit more complicated example of um, using long division to find a quotient. And so I'm going to try to go through this clearly and explicitly, and by the end of this, hopefully you'll understand a little bit more about the intricacies of using long division. So we're going to start off with this dividend. So we have x to the fourth minus x squared plus 5x minus 6. And there's a problem with this. In order for this process to work, you need to have a term with every degree in it from 4 all the way down to 0. So I see an x to the fourth term. Do I see an x to the third term? And I don't. And so I'm going to put a placeholder in here for it. A placeholder is just something that we're going to use throughout the problem to give us a place to line things up. And we're going to end up with some x to the third terms as we go through this. So then we have minus x squared. We have an x squared term plus 5x. And that's our x to the first term minus 6. And we don't have an x on that one. So it's x to the 0. So the first thing that you have to make sure of when you're doing these is that each degree is covered from 4 all the way down to 0. And if you don't have one of those, to put a placeholder in it, it's just going to make the problem a whole lot easier to solve. Okay, now we go to our divisor, x plus 2. Okay. Again, as we go through this, I want you to just focus on that x. We'll use the plus 2, but just focus on that x. Our first term is x to the fourth. We're going to compare x to the fourth to that x. So x to the fourth divided by x is equal to x to the third. 4 minus 1 is 3, so x to the third. And here's the first reason why we need that placeholder, because I'm going to put that x to the third over the 0x to the third. And now watch what happens. So we're going to take that x to the third and we're going to multiply it by x plus 2. So we're going to distribute that in. And we have x to the third times x, which is x to the fourth. And then I have plus 2x to the third. Here's the second reason why I need it. Watch what happens. We have x to the fourth plus 2x to the third. See, we do have an x to the third term that ends up coming into this, and so we have to be aware of that. Now, next step is we're just going to subtract. That's going to change this to a minus. Those first terms, x to the fourth, go away, and that's the whole point. We have 0x to the third minus 2x to the third, which is negative 2x to the third. We're going to drop down our minus x squared. And now we're going to concentrate on this negative 2x to the third. So we have negative 2x to the third divided by x, which is negative 2, and 3 minus 1 is 2, so we have x squared. So we have minus 2x squared. And now we'll take that minus 2x squared and we'll multiply it by the x plus 2. Go in. And again, this step, if you don't need to do the distribution, you don't have to show what I'm doing right now. I'm just doing it to make it clear what we're doing. So we have negative 2x to the third minus, so negative 2 times positive 2 is negative 4x squared. Okay, so we'll put in here minus 2x to the third minus 4x squared. Okay, and once again, we're going to go through here. We're going to put our minus sign. That's going to change the signs on the inside. So we'll have minus 2x to the third plus 2x to the third, which cancels out, and that's the idea. And we'll have minus x to the minus x squared, negative x squared, plus 4x squared, which is 3x squared. So don't forget that negative sign changes both signs on the inside. And now we'll drop down the 5x. So we have plus 5x. And we'll think about now that 3x squared divided by x, which is 2 minus 1, so 3x to the first, or just 3x. So we'll put plus 3x, and we'll do that 3x times x plus 2. We'll go ahead and distribute that through. We have 3x squared plus 6x. So we'll have 3x squared plus 6x. We'll subtract that away. I know this is a little bit longer example, but you'll see why in just a second. That 3x squared minus 3x squared is going to cancel away. We have 5x minus 6x, which is negative 1x. Negative 1x. We'll drop down the 6. So we have minus 6. And then we're going to look at, let's see here, what other colors do I have? Now I can use that color. Now we're going to look at this negative 1. Negative 1. I'm going to go over here to the side. Negative 1x divided by x is equal to negative 1. The x's cancel each other out. Is equal to negative 1. So we'll have minus 1. And we have negative 1 times x plus 2 is negative x minus 2. So we have negative x minus 2. Okay, and last time that we have to do this, we're going to cancel that out. Change both of these to a plus. We have negative 6 plus 2, which is negative 4. All right, on to the second reason why we did this example. At the end, I'm hoping to get 0. I'm hoping to have gotten negative 6 plus 6 equals 0, and then everything is done and the problem is done. However, I get negative 4, and x does not go into negative 4. So what I end up with is a remainder. And I'm going to write this remainder as negative 4 over x plus 2. So minus 4 over x plus 2. And that's how I write a remainder with polynomial division. So here's my overall solution. We have x to the third minus 2x squared plus 3x minus 1 minus 4 over x plus 2. Okay. Now, in truth, I wanted to show you this because I want you to see it. You're going to have to do problems that look like this, but they won't be very many of them look like this. So if you guys have any questions, again, I bet you will on this one, but just let me know and we'll talk in class. Thanks.